1 spoon, 1 bucket. That's the promise going around right now, that this turns dead soil into living soil. I've been through the whole method, start to finish. One idea in it is genuinely useful. 2 steps are widely misunderstood. And 1/2 of the answer is missing entirely. Let's build the whole thing. Here's the method as it's shared. Clean wood ash out of the stove. Pour in vinegar, and it foams up immediately. Let that settle. Add water. Cover it loosely, and let it rest a full day. Then dilute it again. Stir in a few spoons of turmeric, and water it in around the roots. Now, about that spoon. If you're measuring 1 tablespoon into a bucket, what you're really doing is running a trial batch, a small, cautious test on a corner of one bed. That's a sensible thing to do. What it isn't is a prescription. No spoon per bucket ratio can be right for sandy ground in Georgia and heavy clay in Ohio at the same time. The spoon is a trial measure, not a soil prescription. So the real question was never how much. It's what's changing inside that bucket, and whether your ground needs any of it. Start with the ash. Wood ash is not a complete fertilizer. It's a liming material that also carries potassium and other minerals, calcium and magnesium, and a scattering of trace elements. Iowa State puts the typical analysis at roughly 0.13. And that first number is real. There is no nitrogen in wood ash, and there never can be. Nitrogen and sulfur leave as gas while the wood burns. What settles in your stove is the mineral skeleton of a tree. Now the vinegar. That foam is genuine chemistry, and the most satisfying part of the method. Acid is meeting carbonate, and the fizz is carbon dioxide leaving the jar. Here's the part that gets misread. The bubbles prove a reaction is happening. They don't prove the batch has become mild. Fizzing stops for 2 different reasons. Either the carbonate is used up, or the acid is. One leaves you something gentle, the other something still strongly alkaline. The foam can't tell you which, so treat that step as a demonstration, not a safety check. And the amounts are hard to pin down, because ash varies. Its acid neutralizing power runs anywhere from about 25 to nearly 60% of pure limestone. Your stove's ash and mine aren't the same material. Then the dilution. Adding water does lower the concentration, and that's real. But it doesn't erase how much alkaline material is in there in total. Pour enough diluted solution, and you've delivered the same load, just slowly. Which brings us to the turmeric, and this is my favorite part, because what it actually does is more interesting than the original claim. Curcumin barely dissolves in water, and it breaks down fast above neutral pH, with a half-life measured in minutes. It also shifts color as it goes, yellow drifting toward reddish-brown. So when turmeric changes color in your bucket, it isn't treating your soil. It's telling you the batch is still alkaline. Turn that around and you've got something useful, a rough visual signal, rather than a soil medicine. And nothing here is synthetic, nothing out of a bag. But natural doesn't mean chemistry-free. Ash is potassium carbonate and calcium oxide. That's exactly why we wear gloves. So whether this helps your garden or works against it comes down to 3 readings. First, your soil pH. Ash raises it. If your ground already sits at 7 or above, adding more pushes iron, manganese, and zinc further out of reach. Second, your potassium. Ash is a potassium source, and potassium is a nutrient you can absolutely oversupply. Oregon State draws a hard line here, above 600 parts per million. Don't apply wood ash for 5 years. Third, what you're growing. Blueberries, azaleas, rhododendrons, blue hydrangeas. These want the ground sour. Potato beds and fresh seedlings belong there too. A strip test from the garden center will screen you. Your state's cooperative extension soil test, usually $10 to $25, gives you the actual numbers. And from there, 3 paths. Every one of you is on one of them. Path A. Sour soil, potassium needed. Crops that can take it. Ash belongs in your garden. Path B. Your pH is fine. but the ground feels lifeless. Ash isn't your answer. Something else is. Path C. Alkaline soil, high potassium, acid-loving plants, a potato bed, fresh seedlings, or no test yet. Skip the ash, and I'll show you what to use instead. Path A first. Start with what you burn. Clean, untreated wood only. No painted lumber, no pressure-treated, no charcoal briquettes, no trash, no glossy paper. Let it cool completely, then store it dry with a lid on, because damp ash cakes up and won't spread. Sift it. Oregon State soil scientist Linda Brewer recommends hardware cloth with 1/4-inch to 1/2-inch openings. Window screen is too fine. Wear a dust mask, gloves, and eye protection, because this is the same material your great-grandmother leached to make soap. Now the rate. Look at what published guidance actually looks like. New Hampshire suggests a 1,000-square-foot garden, sitting at pH 6.5, needs no more than about 20 pounds. Brewer's yearly limit works out to 100 pounds across that same area. And a Kansas State column, working from one real soil test with a buffer pH reading, calculated around 150, then recommended applying less than the math called for. Those aren't 3 tiers of one recipe. They're 3 soils, 3 goals, 3 ash samples. Which is why your soil test recommendation and your local extension guidance override every rate on the internet, including this one. What you can do is scale their number to your space. If your extension gives pounds per 1,000 square feet and your bed is 50 square feet, that's 1/20th of it. Weigh it out. Don't eyeball it. Then spread it thin and even across the whole area and work it in. Never in a pile. Iowa State warns that concentrated piles can severely damage the soil directly underneath. Time it about 2 weeks ahead of planting, and skip winter spreading, because the potassium and phosphorus wash away before roots wake up. Path B. Your pH checks out, but the bed feels tired. Hard on top, nothing moving in it. More minerals won't fix that, because minerals aren't what's missing. Carbon is. The USDA's Conservation Service narrowed decades of soil research down to 4 conditions, and not one of them comes in a bucket. Cover the soil. Bare ground is the default state of struggling soil. Shredded leaves, mulch, crop residue, living leaves, something over that surface year-round. Cover moderates temperature swings, cuts evaporation, and shields the ground from falling rain. Underneath it, soil organisms finally have somewhere to live. Disturb it less. Every time you turn a bed over, you break structure that fungi spent months building and expose organic matter to rapid burn-off. Less digging isn't laziness, it's protecting habitat. Keep living roots in the ground. This is the one home gardeners skip most, and it may be the strongest of the 4. A root isn't just a straw pulling water up. It leaks sugars and organic acids into the soil around it, and that carbon is what soil life actually eats. A bed sitting empty from October to May is a kitchen closed for 7 months. A cover crop, an overwintered green, even letting a few things stand through the cold, keeps it open. And grow a mix. Different plants feed different organisms. Variety on top produces variety underneath. Then lay down mature compost. Finished, dark, smelling like a forest floor. An inch on the surface, left to work down. Cover, less disturbance. Living roots, variety. That's the half the viral method was missing. Path C. Your soil tests alkaline, or potassium is already high, or you're growing acid lovers, or you simply haven't tested yet. Set the ash aside, literally. Seal it in a lidded can and store it dry until you know your result. It keeps indefinitely, and there's no reason to throw out something you may use next season. Meanwhile, everything you need here is already on your property. Shredded leaves are the best of it. Run the mower over a pile in fall and spread them 2 to 3 inches deep. Left in a corner for a year, they turn into leaf mold, a soil conditioner you can't buy at that price. Grass clippings work, with 2 rules. Thin layers, no more than an inch at a time, or they mat down and go sour. And only from lawns you haven't treated with herbicide. Mature compost, again. And a cover crop over winter, even in one bed. Seed costs a few dollars, and roots do work no amendment can imitate. None of that raises your pH. None of it can be overdosed the way ash can. And all of it comes out of a waste stream you already have. The only thing that may cost you here is the soil test, and it's the best money in this video. 7 places to stop, whichever path you're on. 1. Soil already at pH 7 or above. 2. Soil potassium, above 600 parts per million, 5-year pause. 3. Acid-loving plants, and diluting doesn't rescue this, because the problem is alkalinity, not concentration. 4. Potato beds, higher pH favors scab, safe to eat, but it ruins the crop. 5. Newly germinated seedlings, too much salt, too much pH, too little root. 6. Ash from anything painted, treated, or unknown. When in doubt, throw that batch out. 7. Never in the same pass as ammonium-based nitrogen. Ammonium sulfate, urea, ammonium nitrate. High pH material touching those releases ammonia gas, and your nitrogen leaves as a smell instead of feeding anything. One more for the compost pile. Keep ash under about 5% of total volume, because a high pH can harm the very organisms doing the composting for you. And the most common mistake, on any path, is pouring a homemade solution in a tight ring around one stem, instead of spreading it across an area. Roots feed sideways, farther out than most people picture. Now, one last thing worth knowing, because it changes what dead soil even means. There's a field in England called the Hoosfield Acid Strip, at Rothamsted, the oldest agricultural research station in the world. Barley has grown there for more than 100 years. Along one narrow strip, the soil pH slides from 8.3 down to 4, over about 600 feet. Same field, same weather, same crop. Researchers sequenced that strip end to end. The amount of microbial life barely moved. Fungal biomass, bacterial biomass, total microbial biomass, steady across the whole gradient. What changed was who was living there and how fast they worked. Growth rates shifted dramatically, and the ratio of fungal to bacterial activity climbed roughly 30-fold as the ground turned sour. A separate study sampled 98 soils across North and South America and found the same pattern. Soil pH was the strongest predictor of which bacteria live in a soil, not how much life, which life. So your tired bed probably isn't dead. It's running a different crew at a different speed. Ash can shift that crew where the ground is genuinely sour. Carbon, roots, water, and air are what feed them. And if you want to watch that happening, there's a test the Conservation Service actually runs. Bury a pair of new all-cotton briefs about 3 inches down in May or June. Dig them up 60 days later and see what's left. Read it carefully, though. Moisture and temperature drive that result as much as biology does. Do it in 2 spots, one under mulch and one in bare soil. So, 1 spoon, 1 bucket. Here's the honest answer to it. The spoon is a trial measure, not a soil prescription. The ash is real, and it's free, and it belongs in some gardens and not in others. The vinegar makes a fine demonstration and a poor safety test. The turmeric is a color signal, not a medicine. And the missing half, the half that actually builds living soil, is carbon, roots, water, and air. Path A, spread thin by the numbers. Path B, feed it. Path C, store the ash and use your leaves. One line to carry with you. Test first, spread thin. Feed life with carbon, roots, water, and air. Now tell me something. What state are you gardening in, and what was your last soil pH? I read them, and there's a real map of this country hiding in those answers. And one last thought before you go. The ground under your feet has been holding on a good while longer than you have. It doesn't need rescuing so much as it needs tending, a little cover, a little patience, and roots given somewhere to go. There's grace working down in that soil, quietly, and it was working long before any of us picked up a shovel.